I'm happy to announce our next speaker. It's Ben Woolford-Lim. I hope I pronounced your last name correctly. So he is a senior developer at the Allotrope Foundation, and he will speak about the Allotrope Working Groups and release updates. So happy to have you here, and looking forward.
Thanks very much. So as I said, howdy all. Ben Woolford-Lim, senior developer at Allotrope. I'll just give a quick overview of how we've done since the last one of these meetings in the fall. Okay, so so as stated, we'll just quickly go through updates from the two releases since the last meeting. Then updates from all of our active working groups: the modeling, chromatography, mass spec, plate reader, and flow cytometry. And just that'd be good. Yes, it would be helpful not to have to hold everything. Okay, so for those of you who aren't so familiar with Allotrope, I'll quickly run through our product suite. We have 4 products out there because, funnily enough, these updates are going to cover all of them. We have the ontologies, which you've heard a fair bit about, and we'll hear more of later on. The control vocabularies and the relationships between those terms. That one, as well as the ASM towards the end, are both public standards. They're available to everyone for free. The ADM is the Allotrope data models. That's the semantically enabled data models. They're sort of how you build these data sets to work together in an interconnected semantic way. That product, along with the ADF to the right of it, is our member benefits that are not available to the general public at present. The ADF format, again, which you've also heard some of, is the data format that's used to basically store all of this semantic data, as well as the raw binary data in a single well-encapsulated format. Last but not least, we have the simple models themselves, the JSON representation of the data models using the Allotrope ontologies as backup terms. Sorry for going over it for those who have done it before. My talk was previously going to be scheduled right at the start of the day, so it made sense to include this. So in terms of updates since the last Allotrope Connect, we've been working further on modularization of the Allotrope simple models. We've established a common hierarchy schema, things that no matter what technique you're talking about, everything should have, things like the sample document, things like the analyst who's doing the experiments. So we've been working on expanding that common core set and also implementing it to a wider range of the techniques that we currently capture. We've had a release in Q4 of last year, which included 2 new models. The solution analyzer, that supersedes our previous blood gas analyzer model and adds support for a few more detectors. We established that, similar to the plate reader, solution analyzer is really more of a sort of a central model that can have multiple detectors attached to it. So we now have a model for that can capture things as well as blood gas, things for like pH, metabolite analyzer, osmolality, cell counting, and absorbance. Benchling also put forward a model for the digital PCR. We had a qualitative PCR model previously, so we've now used that as a basis for a digital PCR model that was released at the end of Q4 as well. We also had some updates to the Allotrope data models. So as part of this modularization effort that started sort of middle of last year, sort of a significant portion of that work was done in Q3 for the ASM, the simple models. The ADM artifacts weren't ready for release in Q3, so those were pushed back to Q4 and released as part of the last quarter, the end of year update there. In Q1 of this year, we had a couple of new models again. We had the spectrophotometer approach from Benchling. So we already had UV absorbance, fluorescence luminescence as part of the plate reader model, but it was determined that, again, you could have a standalone device, something that just did spectrophotometry and not necessarily in a plate form. Benchling raised this as a point of interest, so we now have a model to capture that modality as well as the plate reader form. They also put forward a request for multi-analyte profiling. One of the common things being Luminex or XMAP, so the idea of bead-based immunological assays. So we now have a model for that approach as well. There were further updates to modularization. Our hosts requested updates to some of the models that they proposed previously for the temperature, pressure, and pH sensors, as well as the stirring. We also did an update to the tensile test model originally proposed by Dow, as that was also of interest to the ASF. So those are now in line with our new modularization hierarchy. Similarly, we had new detectors added for support in chromatography at the request of MSD. So you can now have fluorescence, ELSD, radioisotope flow, polarimetry, and refractive index data stored in our chromatography models in the ASM. Q1 release is now available on all of our usual local hangouts, so GitLab, the ASM public repo, again, that being the public resource for those that aren't current Allotrope members, Perl, JFrog and Client Connect, as well as the Allotrope website. You can download AFO and ASM from all of that. Well, AFO from all of those sites, ASM from the public repo and from Perl. We also have various ontology lookup services that are currently indexing AFO. Bioportal, OntoB, and OLS4 all include the Allotrope Foundation ontologies as a matter of course now, and the 2024-03 release is available through those if they happen to be your source port of call for ontological information. We also learned that a new service, at least new to us, the TIB terminology service has started indexing us as well, so we're now listed there. In addition, I'm not sure if that one picked up 2024-03. We need to go and double check that, but it's certainly started picking up Allotrope as part of its coverage as well. So we're expanding. In terms of the 2024-01 release, it went very smoothly. The team's been, Amnon in particular, has been very heavily invested in getting DevOps tooling up to speed, and it's making a significant difference, I would say, in the release process. As I said, the Bioportal, OLS, and OntoB services that pick us up do so without any human interaction now. They just pull us straight in, so we don't have to actually go through any release process. That used to be a manual step on our part, but we've been able to automate that, as well as building in a lot more of the QC/QA checking that's been requested of us in the past, with further improvements hopefully to come. So another note to the community: as of the Q1 release this year, the team has opted to move to working on ADM shackle artifact in particular by request. Given the sort of significant interest in the simple model, the ASM, and the limited engineering time we have available to work on the artifacts and the sheer growth of demand in that area, it's been determined that shackle and ADF artifacts, which are relatively less used, will be generated by request. So if any of the members require these artifacts, we can generate them, but they won't be pushed as part of the quarterly releases anymore by default, just to save on time. So if you have a particular model that you need an update for in the need the specifically semantically enabled artifacts for that, please reach out and we'll make sure they get included, but otherwise it won't be done by default. We also had a release of the ADF library this quarter. 1.5.6 release final was released early in Q1. It's available in the usual places, Client Connect and Artifactory. It includes a new feature to allow compression of data package data during import, because as has been mentioned in the previous talk, ADF file sizes can be a bit large sometimes. We also added some more guidance on handling Unicode characters, Japanese characters being the key example. due to the underlying HDF5 library not supporting Unicode characters very well in places, we've had to add some guidance on what can and can't be done. Allotrope had some mitigations in place, but they were causing confusion as to when it worked and when it didn't. So we've added some improved guidance on what does and doesn't work in that respect. Again, we've got some more CI DevOps pipelines for the ADF repository that have been cleaned up and improved. All of these and more information in general can be viewed from the GitLab milestones and issues tracker for the project. On top of the release final for 1.5.6, we also have a release candidate for 1.5.7. The primary change in this is an update to the underlying HDF5 library to support both the standard x86 64 architectures that Windows and Linux users know and love, but also to include ARM capability for the new Mac books that use Apple Silicon, I believe, based on ARM. So the release candidate for 1.5.7 includes the version of HDF5 114.3 that supports, as well as the standard things, thread safe and zero compression, the computer architectures for Linux x86 64, Windows 64 and 32-bit, and Mac OS, the standard Intel PC, but also the new ARch 64 approach. So if you have a new MacBook and you want to be running ADF on it, you might want to give 1.5.7 RC a try. Further announcement on the ADF, as of the end of this quarter, the support and maintenance of ADF is being moved to a community-based model. So Allotrope can look to accept code contributions or funding to enhance or support the existing ADF library, but again, due to the general interest in ASM and the lower demand for updates to ADF, we're reducing our support commitment in that regard to community contribution and product team support rather than a dedicated contract for ADF. So the up-to-date list of models, as usual, it's available on the Allotrope webpage. Product releases, allotrope.org/product releases. We have a current count of 62 models in recommended status, including, and there's also a list of upcoming models either currently under discussion or announced on the horizon as a potential future a little further down the line. The newsletter for the latest quarter is also available at the top of the page, so if you're interested in seeing just what happened over the last quarter and you fell asleep while I was talking about it, please feel free to go and take a look up there. Now to the sausage making, as it were, the working group updates. We'll start with the modeling working group. As mentioned, we had a bunch of new models over the last 2 quarters. This was the group that put through the 4 new models: solution analyzer, DPCR, spectrometry, and the multi-analyte profiling. We've also been discussing some of those common hierarchy questions. We've come to resolution on image aggregates. There's some discussion around how do you store images in the ASM. We had an approach, but the original approach didn't fully capture some of the nuance that we need for things like optical microscopy, which is a topic that's likely to be coming further down the pipeline. So we had some discussions on that and clarified how we should be storing things in the case where you have multiple image files related to a single measurement. So discussions of that kind of ilk take place through that group fairly frequently, and that's one of the resolutions we came to. Alongside that, we also have some new modular documents, again expanding that common repertoire of things that aren't limited to a single technique but go across the playing field. The idea of a regression model document proposed by Benchling and supported by MSD. So that's how we're likely to be capturing things like calibration curves, but also things like standard dose responses, things that aren't, again, unique to a specific technique, but it's a general pattern that we know we're going to need to capture in multiple different places. The idea of an error document has also been put forward to capture something went wrong with a particular measurement, not with the whole thing, but one of the fields is out of spec, so that was put forward as a suggestion on how to capture that. And as I mentioned, we're talking about optical imaging as a future update, both in the plate reader sense and also an update to our existing optical microscopy model, which needs modernization as well. So we'll be probably working on those in tandem, both through the modeling working group for the standard technique and the plate reader group for the plate reader detector version. There's also an NMR model currently in progress. Wes Schaefer from MSD has been presenting that and putting that forward. We already have a qualitative NMR model. The current suggestion is to unify that into our existing general purpose, or into the proposed general purpose model to capture qualitative or in a consistent way, consistent with the proposed general purpose model. We've also got some a new face for this particular discussion, so welcome to Dimitris from ACD Labs. He's been extremely helpful in providing NMR expertise, something that it turned out we were severely lacking before that point, so that's been an extremely useful addition to the group for this project. So. This group's pretty productive. We've got plenty of things on the horizon. So as mentioned, we talked about the regression model. That's going to be the feedstock for the idea of a calibration model for both devices and also for measurements. There's been debate on which one we handle first and how unified they are. But there are different kinds of calibration. It's one of those overloaded terms in our industry, but we're working on how to model that. MALS, multi-angle light scattering, has been put forward again by MSD, so that's another thing that's potentially on the horizon. We've got capillary electrophoresis. That one's actually pretty close to ready. It's pending some of these underlying discussions. MSD and Benchling have both put that forward. The model is mostly complete, pending cleanup of those last couple of little issues. Because it's a technique that is frequently used through chromatography data systems, although it's not chromatography, it's going to be reviewed by the chromatography working group as well as the modeling working group to make sure that there aren't any issues with inconsistency, because although it's not chromatography, there is a strong tie there. We're looking to do an update to the automated reactors model, probably this quarter. That's one of our larger tabular models from the previous stable that needs modularization with the new patterns. So that's going to be a fun job. That'll be hopefully a quick, fun job for this quarter. Liquid handling and imaging and microscopy are also on the table. As I mentioned, imaging is probably the next one, I suspect. Our hosts have been requested we look at rheology as a future model, so that one's on the list, and then more of the modularization updates. So QNMR, which again probably is now going to feed into the standard NMR model, the balance and the X-ray diffraction model are on the table for later this year. Hopefully we'll get through most, if not all of them, by the time we speak next. That's, I think, it for the moment for the modeling working group. Chromatography has also been busy. We have, as I mentioned, added support for the various external detectors. I'm not going to list them again because I'm sure you can all read. We're also working on an extended chromatography column model. So there's a desire within the community to have a column database, something where you can basically, look up what columns do I need, what are the capabilities, and more to the point, if I don't have this particular column, what else can I use? So some of that is currently available, not all of it. Allotrope was asked if we could help with that, and so we're looking at building the chromatography column model to help support. This is the data you really need to know about a column, and this is the format you want it in. We'll also be working on, obviously, the ontology terms. These are the words you want to use to make sure that we're capturing these things in a consistent way. As I mentioned, some existing tools are out there. The main one that I'm aware of is hplccolumns.org. So that's a database that lets you determine the hydrophobic. I've lost the second word, selectivity, I think it was, of a chromatography column and establish whether it works well, and whether you can use a different one with a similar capability. So Dwight Stoll from Gustavus Adolphus is heading up that project. He has now joined the Allotrope Working Group along with Matthias, who we've already heard from, and Jeff Schick from USP. All of them are working to see if we can't make something useful in Allotrope that can be then built into this upcoming column database with luck. So we have an example model for the chromatography column. Wes from MSD very kindly provided some sample data from Waters. They previously started work on a project of this type, so had some of the background information. So we have a fair amount of information on Waters columns. If anyone happens to have a collection of Agilent columns or Chromaticons or anyone else's columns that they would like to share with the group, please feel free. More data is always useful, especially when it's different sources, different vendors. Make sure that whatever we build works across the community and not just this particular case, this particular manufacturer or anything like that. So on top of chromatography columns, as I said, we have more models on the horizon. The group will be reviewing capillary electrophoresis. We've also had an interest in a supercritical fluid chromatography model. We already have one in the graph form, but we don't currently have a tabular or ASM format model for SFC. GSK has expressed an interest in that, so with a bit of luck in the coming quarter or two, we'll be working on that one and see what we can do to extend that number of models to 63 and beyond. Mass spec group is also ongoing. We're working on a quantitation MS tabular model. We currently have input from various members. We're looking to get more data on this. So the current we have a model proposed, but we're looking to test it a bit more broadly with a few more data sets. We have the generic model, but we're looking to specialize into quantitation, and that's currently a bit of a blocker. Genentech has been able to share a little bit of data with us. We're currently working with them to fully extract the information that's needed. The data we've been able to get so far has been in bits and pieces, because one format includes this information, one format that includes that information, and as we all know, it's never quite what you want or in quite the format you want. If anyone else is interested in quantitation mass spec and is able to share some data, again, please reach out. We can always do with more, especially if we can get that complete data set together, or from different manufacturers, different vendors, different software sets. It's incredibly valuable to have that breadth of data to work with. Heiko has also in the past demonstrated a proof of concept for an LCMS viewer for centroided data. There's still some work ongoing on that. I know that I need to catch up with him about how to represent that in the Allotrope tabular, Allotrope simple model, sorry. But yeah, we've got work ongoing on that. And we've been recently analyzing the use of adducts in the LCMS model. So the term adduct itself has been a bit of a contentious one, because sometimes you have losses, and those really aren't adducts if you're talking about additions. So that's been a contentious point, a point of discussion within the group, whether we can establish a common list of adducts that you can pick from in the ontology, rather than just having an open data set where people can type whatever the hell they want, and generally speaking, 3 different ways for the same thing. We've definitely seen that in the data we've looked through so far. So yeah, that's the mass spec update. Plate reader, almost there, promise, only 2 groups to go. The plate reader group has been hard at work, less hard at work because we've moved to bi-weekly meetings to free up time for all of the other groups that everyone's involved in. We've been working on the UV absorbance spectrum data cube, as well as kinetics for plate readers. As we know, Benchling's been very busy with implementing adapters. They've actually implemented 2 adapters for the plate reader model so far, one for the Envision from Perkin and one from the Softmax Pro from Moldev. As I said, the team's working on kinetic reads, and for those who aren't particularly familiar, that's basically reads over time. The existing plate reader model supports point measurements, one measurement taken per well. This is how to handle multiple measurements over time taken per well. So we have an approach planned for that. We're just basically crossing the I's, dotting the T's, and that should be going out in Q2 with any luck, without too much issue. Last but certainly not least, we have the new Flow Cytometry Working Group. As I said, it's new. It was initiated at the last Allotrope Connect, so it's been going a little less than 6 months now. It's chaired by Joe Negri of Benchling as of earlier this year. If you're interested, it meets every other week on a Friday from 11 to 12 Eastern. Please reach out to me or to Amnon if you would like to join. We can certainly get you added to the list. We have representatives from a range of different companies, Benchling obviously as the chair, but also MSD, Genentech, Agilent, GSK, Ganymede, Zontal, and hopefully you very soon, if anyone's interested. So the group so far has been discussing, setting out the scope. What is it that we actually need to capture? There's a strong desire to reuse existing standards because, at Allotrope, we try not to reinvent the wheel too many more times. It's been done a few times out there in the industry so far. We try not to contribute to that because, the nice thing about standards, there's just so many of them. So there are several existing standards for flow out there. Two of the notable ones that we're going to leverage are the FCS standard. That captures single samples per file. It is as ubiquitous a standard as I've ever seen. So our general consensus is we're not going to play in that space. FCS is the standard. There's no point us trying to usurp that or change it or just make more confusion. Our intent is to basically standardize at a level above that because that, at the moment, appears to be the Wild West. Gating ML is another standard that we're going to leverage. That one's got slightly less inroads compared to FCS, so we may do a little bit of overlap with gating and just use FCS as the underlying data store for the flow repository, the flow cytometry model. Existing flow standards are flow-specific, unsurprisingly. They're not cross-cutting like the allotrope models. So our aim is to standardize at a higher level and at a level where you can then take that information and join it with our chromatography or our mass spec or our plate reader data in a way that you can use them all in a nice, consistent form. So that's where we're seeing the gap that Allotrope can fill. And to that end, the initial focus will be on aggregation of those process data results, taking the SCS files and, putting them all together, doing some processing. And what you tend to get out at the end of the moment is an Excel file in absolutely unintelligible formats because everyone does it differently. There is no standardization there whatsoever. That's where we think we can aim and do the most good. So we have a skeleton for a flow model presented by Benchling. We've got some sample data coming from Genentech and MSD, a list of open questions, some of which the group's already discussed and tackled around things like querying data across multiple channels. I think we've covered how to use FCS, and as I said, we're going to sit above the FCS file. Describing gates and populations is an ongoing discussion, and then other flow cytometry standards or ontologies to consider, which we've done the homework and are going through that now. So I think that's about it. So any questions, Liz?